All right, we are live with SQL Friday number 64, and our guest today is Guy Glantser, who is going to talk about extended events to the rescue. And for those of you who are still using Trace, this presentation is for you.
Yeah.
And for the rest of us who are actually using extended events, I think it's for us as well, because there is tons more in extended events than at least I have explored. So
Absolutely.
Welcome to SQL Friday, Guy.
Thank you.
Very nice to have you here. People, when you do if you have questions, type the questions in the chat and I will try to interrupt Guy where it's convenient. So the rules for microphones are, if you're named Guy Glantser or Magnus Hallqvist, you can have the microphone on. If you're not, then it should be turned off. So the stage is your, Guy.
Great. Thank you very much, Magnus. Very happy to be here. So yes, we're going to talk about extended events. And yes, I would love to get as many questions as you have. Feel free to ask questions. This is the whole idea, to learn. Let me introduce myself first. So again, my name is Guy. I'm a data platform MVP. I've been working with the Microsoft data platform for the past 25 years or so. So I've seen a lot of stuff. I made a lot of mistakes. I learned from them. And here I am today to teach you some of the things that I learned. I blog. You have my blog here. We have a podcast, SQL Server Radio. So it's everything about SQL Server, events, community events, new features, projects. We interview people once in a while, whatever about SQL Server. You can get me on Twitter. You have my email address here. Feel free to reach me, ask any questions you have. If I can, I would love to help. I work for Madeira Data Solutions. We are based in Israel. We provide services worldwide, services, solutions, again, around the Microsoft data platform. It used to be just SQL Server back in the days. Today, it's mostly Azure data services, and of course, SQL Server as well. And yeah, I think that's it about me. And let's talk about extend events. So I'm going to answer those questions today. I will try to answer the question. What is it, for those of you who don't know, and why I think you should use it. And of course, we're going to see lots of use cases and demo. I have lots of demonstrations to show you. So let's start with what is extend events. If you go to the Microsoft documentation, you get this. Okay, I will not read it. It's quite long. General event handling, blah, 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 blah. Okay. So really, what is extend events? It's a monitoring platform. Okay, so again, like Magnus said, I believe most of us, including myself, are used to SQL Trace or Profiler for many, many years. It's still there, it's still here, and still most of us use it. And extend events is it's an alternative with several benefits and advantages, which I will cover in a minute. Another way to monitor SQL Server, to get events, to troubleshoot what's going on inside my SQL Server machine. Okay, so that's what it is. And let's talk about how it looks like. Okay, so a bit about the architecture, the internal architecture of extend events. So extend events is quite a wide monitoring platform. It begins with modules. So you can register your own application or all types of application. You can register it as a module inside the extend events architecture. And then within any application, basically, you can throw events, and then you can consume those events. So SQL Server is one of those modules, which we are going to cover today. But if we look at the entire architecture, you have modules. Within each module, in our case, SQL Server, you have packages, which a package is kind of a container. It's like a namespace. And inside each package, you have lots of different objects. So everything you see here is basically an object. It's like it's quite a generic architecture. You got objects, and then you have object types. So you have objects of type events, you have targets, which is another type of objects, actions, types, predicates, and maps. Okay, so this is basically the architecture. I'm going to show you later using some scripts, which events you have, which targets, what it means, and so on. When you create an event session, okay, so you have all those. Okay, someone is not following your instructions, Magnus. Some noise.
Let me see. There we have David. I'm going to mute you.
All right, thank you. So we have those objects, and think about it as a repository of objects that you can use. You can decide which events you want to use, which targets, which actions, and so on. And when you want to monitor SQL Server, what you do is you create an object called event session. You start an event session, similar to a SQL trace, if you like. And inside an event session, you can choose which objects you want to use, which events, for example, you want to monitor, which targets you want to write the events to, which actions, I will talk about what actions mean, and more and more. So basically, you have an event session. In this example, you have session 1, session 2. And what I want to stress here is that within each session, you can mix and match. Okay, you don't have to use objects within a single package. Okay, so just as an example, you have package A, package B, package C with all kinds of different objects. And within session 2, I say I want to monitor event 1. I want to write the event to target 1 and target 2 in parallel. And I also want to add action 1 to this event session. Again, I will explain in a minute what it means. Okay, so that's basically the architecture. Now let's talk about profiler or SQL trace versus extend events. When Microsoft shipped extend events within SQL Server, it was meant to replace profiler. I think it's still meant to replace profiler or SQL trace, but it's still here many years after the first launch. I think it was 2008 when extend events was first introduced. So yeah, it's meant to replace profiler. It has a lot of benefits, and I want to show you. This is from you have the source here. I'll put the. Oh, I can't do this. I want to put the link in the. Where is it? Here. Okay. So this is if you want to look at the source. I'll put it in the chat. Okay. This is Jonathan Keheyas. If you don't know Jonathan Keheyas, you should, from SQL Skills. He talks and writes a lot about extend events. I can say that I learned a lot about this platform from him. Okay, so I highly recommend that if you want to learn more about extend events, and I will show you some other useful links at the end of the presentation, follow Jonathan. Okay, so this is one blog from 2012. It's quite old, but it's still very relevant. He did a very thorough benchmark comparing extend events and trace file as well as profiler. Okay, and you can see the results here. So he had a baseline, some tests, running all kinds of requests against SQL Server, and he started monitoring first the baseline without anything. Okay, no extend events, no trace file. He used, I think it was a performance monitor to capture the batch request per second, the entire batch duration. Okay, so you get the results here. There is the observer effect. When you use a monitoring platform, you have to take into account the observing effect. So if you're going to use Profiler, for example, Profiler has an impact by itself, and you use Profiler to troubleshoot performance problems, but maybe you are the one actually causing most of the performance problems using Profiler, or maybe not most of them, but you have an impact. Okay, so you need to take that into account. So what this table here shows you is the observer effect. So this is the baseline using extend events with an event file target, meaning you write to the file system, to a file. You can see the degradation in performance. Okay, so this is the observer effect of extend events. When you write to the ring buffer as a different target, which means to the memory, you can see this. It's quite the same. Okay, it's not such a big difference. Okay, you might be surprised because writing to memory should be faster than writing to disk, right? So there are some issues with the ring buffer targets in extend events you should be aware of. Okay, and this is why it's a bit slower, but it's basically the same. I will talk about this later. Okay, we get to the demos, and then let's compare it to a trace file. Okay, so if you don't know, a profiler is just a client tool. The technology behind profiler is SQL trace. Okay, and you can create a SQL trace without using profiler as the client tool, using some scripts, and you can decide that you want to write the events from the SQL trace to a trace file. And that's what Jonathan did here. So you see the impact. You see quite a big difference already between extend events and trace file. Okay, trace file has a lot more impact. And then when you start to use profiler, and there are two options: use profiler from a remote machine, or use profiler on the same SQL Server instance machine. Here is the big jump. Okay, so it's not even related to the extend events. Okay, just that you know, profiler itself as a client tool has a huge impact on performance, a huge observer overhead effect. Okay, and you should know. So if you're going to use Profiler even after this session, I hope you're not. But if you're still going to use, SQL Trace, don't use Profiler in the production environment. Okay, unless you don't care about the impact. Use a SQL Trace file with server-side scripts and write it to a file. There's a big difference here. Okay, so this is as far as the impact, the observer effect. Okay, let's see some demos. This is just blah blah. Here about the demos, right? So let's start with the architecture. With extend events, first of all, okay, maybe before that, we have UI starting SQL Server 2012. If you go here to management, we have extend events, and there you have the session. I talked about event sessions earlier, so here you can see all the sessions. There are several built-in default sessions when you install a new SQL Server instance. One of them is system health. It comes with a session. It's similar to the default trace with SQL Trace. There's also always on health. If you configure and set up availability groups, then when you use the UI, one of the things it does behind the scene, the wizard, is to enable to start the always on health event session. As you can see now, using this icon, it's currently stopped on my machine. And of course, you can start your own new session or using the wizard and so on. Now, I don't like to use the UI. I always prefer to use scripts because then you can reuse them. You can share them with others. And you learn more when you use scripts because you have to understand the syntax, you have to understand what it does, not just clicking next, next, next. So I'm not going to use the UI. For some people, I know it's more convenient. It's up to you. I'm going to use scripts during this session, during this demo. And if you want to look at the architecture, the metadata of extend events, we use DMVs, okay? So sysdm XE, extend events, and then you have all kinds of DMVs. The first one is packages, okay? So I talked about packages. Depending on the SQL Server version that you use, you're going to see different results because with each new version, Microsoft adds new packages, new objects, new events, and so on and so on. So I'm using SQL Server 2019. So these are the different packages that I have on my machine. Again, they suggest containers, namespace. Okay, no big deal about that. But usually we're going to use the SQL Server package, sometimes the SQL OS package, operating system, depending on what you want to monitor. If you want to deal with SQL CLR, for example, there is a package for that, and so on. Next, I'm going to show you all the events that we have in SQL Server 2019. So for that, we're going to use objects. Again, everything is an object within extend events. We're going to join it to package, and I want to look at all the objects of type event. So these are basically all the events that I can monitor within SQL Server. We have 1,841 in SQL Server 2019, and again, it increases with every version for two reasons. One, we have new features, so Microsoft also adds events for those new features, and second, we have new events for existing features. So it gets improved all the time. Okay, so file stream, for example, query store, if you want to monitor that, lots of stuff here. As you can see, most of the events are from the SQL Server package. And then let's take one specific event, SQL batch completed, for example, which is very, very common. I'm going to use it in the demos as well. And I want to see the event fields. So each event has associated fields. Okay, so then we join to another DMV, sysdm XE objects columns. And I want object type events and the event name SQL batch completed. I want to see the columns, the events, fields. So these are the fields of the SQL batch completed, just as an example. And as you can see, we have three types of columns or fields. One of them is data, which is the most important one. This is the data that we can get back from the event. So each time a batch completes, if I use this event in an event session, I'm going to get an event with these columns: physical reads, logical reads, writes, fields, and so on and so on. Of course, I can order it. Maybe it would be better to sort it next time. We have some read-only fields, which is not really important for us right now. These are system-generated, built-in events like the version, UUID, channel, keyword. Not really interesting for now. We also have sometimes, not always, depending on the event, we have customizable event fields. A customizable event is one that you can set. You can decide, in this case, collect batch text. So you have SQL batch completed event, and as part of the event session definition, you can decide whether you also want to collect the batch text or not, okay? And here you see the default value, which is true. The reason we have those, and this is an example of a difference between extend event and SQL trace. In SQL trace, you have events, you have columns, it's like a table, and that's it. Here you have more control, and you can decide which events you want to capture for which fields you want to capture for each one of the events. And this is one example. And the idea is to reduce the impact, okay, to have less overhead. If I don't need the batch text, there's no need to capture it because it has some overhead. Everything that you capture and you register and you store it in somewhere in the memory or in a file, whatever, it has some overhead, okay? So we want to get the minimum that we really need. So we have data, read-only, and customizable. Let's move on. I talked about actions. So action is another type of objects of type action. And action can be a bit confusing because generally speaking, action is actually a global field. Okay, so you have the event fields I showed you earlier, and for each event you have different fields. You also have a global list of fields that you can use with any event. So as part of the event session, again, in order to reduce the overhead, we don't get all of those fields by default. We need to specifically say, I want to capture also this field and that field, this global field and that global field in this specific event session. Okay, so you get things like the process ID, CPU ID, scheduler ID, and so on and so on. There are more important things here like the plan handle, for example, if you're going to go and grab the execution plan or the session ID, and so on and so on. Okay, so they are called actions. They're actually global fields. And then we have targets, which I think is the most interesting thing about extend events. Again, it's a type of object. We have many types of targets. The most common ones are event file, simply write to a file, ring buffer, simply write to memory. But we also have some interesting targets like histogram and pair matching and some other things. I'm going to show you some of them, at least not all of them in the demo. And this, I think, what makes it different from SQL trace, for example, because if all I need is to use a histogram, is to count events, okay? Let's say one of the demos I'm going to show you, I think it's, monitor logins, this one, okay? I want to monitor to know the distribution of connections between different logins in my system. I want to know if a login is heavily used or never used or only once a day and so on. So what I can do, I can create an event session to monitor logins. There is an event for login. And instead of just writing all the login events, which is a lot of overhead to a file or to memory, I only want to hold a very small structure in memory, which is a histogram, which means for each, think about it like a group by query. Okay, so group by login, and then count the number of events for each login name, I mean. Okay, so it's very, very efficient if this is what you need. So it's very interesting to use different targets. And for each target, you have different attributes. And again, based on the same generic architecture, we're going to use object columns with a type target and a specific type of ring buffer. So in this case, instead of event fields, the object column is going to return the target attributes. Okay, so this is an example of the ring buffer. You can set the max memory, the occurrence number, and the max events limit to limit the memory that you assign for this event session. And the last thing is map values. Because extend events uses many different lookup tables. Okay, they are called map values. You have the name of the lookup tables. Let's look at something that is more familiar, maybe like, okay, forget about it. But each table has its name. You have the ID and then the map key, the map value. Okay, so sometimes you're going to need to use them when you filter, for example, an event. I want to get, let's say, weight types. Okay, this is a great example. If you have weight types, I want to monitor weights, but only the CX packet weight type or only specific weight types. Okay, so you can use a filter and say, I want these specific IDs. You need to go to the map keys and map values to see what is the map key of the CX packet weight type, for example. Okay, because it's specific to the extend events architecture. So this is about the architecture, the DMVs, the metadata. Any questions so far? Anything, anyone?
Nothing that has come in. So, and people, don't be shy. If you have questions,
Sure.
Now is the time for it. So.
Please do. Okay. Yeah, I see a question here, right?
Yeah, it came in now. Adding different events, I often find myself repeating exactly the same work condition for every event. And then an example with a where clause and SQL server.NT user is not equal to blah, 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 blah. Is there a way around this repetition, something like session-wide set and conditions?
Okay, good question. The answer is no, unfortunately. There is no such session level or server level condition. Each event session has its own definition. And yes, you need to repeat yourself if you have something that you put everywhere. But again, that's where scripts come useful compared to UI, for example. You have a script with relevant filters you need, just copy and paste, change a few things, and you're done.
Yeah. And I'm an advocate for using read-grade SQL prompt and the template function in there. It's very useful for it.
Yeah, I agree. Okay, so let's start with the first demo, batch execution. So what's one of the most common use cases for monitoring, whether it's extend events or SQL trace, is to monitor for batch executions. Whenever a batch completes, like I showed you earlier, SQL batch completed, I want to get an event and I want to analyze it to see duration, CPU, reads, and so on and so on. So let's look at the syntax. I'm going to start an event session, create event session, give it a name. On server, there isn't another possibility here. It's part of the syntax as of now. You always need to write on server. And then you start adding events. So you can add multiple events this way. Add event, in this case, this is the package name and the event name. Okay, two-part name, similar to how you use two-part name with the SQL Server object, schema.table name. So package and object name, SQL batch completed. And then I can add filters, for example. So I want to get all the SQL batch completed events where the duration is more than, this is microseconds. And if you're not sure, of course, go and check either the DMVs I showed you earlier, because there is a description and it says this is in microseconds, or of course, Google it. You'll find it. It's quite easy to find it. So in this case, I want all the events of batch completed with the duration more than 100 milliseconds. Okay. I also want events RPC completed, remote procedure call completed. In this case, for a specific application name, which uses in its connection string application name problematic application. This is an application that I like to use in many sessions. It causes a lot of problems. And of course, I can add more. What's important to know, and again, this is not related specifically to extend events, is every batch, every request, everything that runs within SQL Server is either a batch or RPC. Okay, so if you want to catch everything, you need to catch batch completed and RPC completed. Okay, those are mutually exclusive. So a batch can be either this or that. And this way you're going to catch everything. RPC completed is when you issue a stop procedure, for example, from an application, a .NET application. So you run a command type stop procedure. It registers as an RPC completed event, remote procedure call. Mostly anything else is SQL batch completed. Okay, so we have two types of events. And then we add a target. In this case, I want to write to the event file target, which is very common again, a file in the file system. And I'm going to write to this specific file. In very old versions, there was another metadata file, XEM, I think it was called. At some point, Microsoft removed it. You don't need it anymore. You can just specify the XEL. And the extension is not mandatory. Okay, you can put it whatever. Okay, it's like a best practice, similar to MDF and LDF, which is very common, but you can actually put any extension that you like to those files. So I'm going to start to create actually the event session. When you create an event session, by default, it is stopped. It's not started yet. You need to run this command to start the event session. So now it's running. You can see in the GUI, if I click refresh here, then now I have batch executions. I can see that it writes to event file. I have some, again, properties. I can look at the things here, but I don't want to use the GUI too much. So now it's running. Let's run some stuff. So first of all, is my, no, not this one. Here it is. I'm going to run the problematic application. Okay, it's a console application that runs some stop procedures behind the scenes. We don't really care about what it does at this point. And I'm also going to use here test statements. I'm going to run some statements on AdventureWorks 2017. Okay, let's do this. And then I'm going to use this. Now, one of the things you need to know, and it's time to tell you about it, about extend events, you need to know XML and XQuery. You don't have to if you're going to use the UI, and maybe it's good enough, but I think that for many cases, if you want to really analyze what's going on, you need to know XML and XQuery, because everything within extend events is stored as an XML. You have an event data column, which is an XML, and everything is within this XML. And you need to use xquery, like I'm doing here. Okay, so I'm doing cross-apply nodes, and then I take all the event elements within the XML, and then I'm using the value method of the XML data type to get the name of the event, to get the what do we have here? The timestamp and the duration and so on and so on. Okay, so you need to know how it works. It might be not very pleasant at the beginning, but when you get used to it and you get you have your scripts ready and you can reuse them, it's quite convenient and very easy to use. Okay, so in this case, very quickly, I'm going to show you. I'm using a CTE here to select from this function, similar to we have a similar function using a SQL trace to read from an event file. Okay. Look here, I'm using a wildcard because I might use different files with different numbers and so on. So I want to read the entire folder in this case, or maybe not, depending on what you mean. But I just wanted to show you that it supports wildcards. So this will give me, let's run only this. I will see a bunch of XMLs. Each one is an event represented by an XML. You see some of them is SQL batch completed, some of them is RPC completed. Let's click on a random one, RPC completed. You get the event and you get all kinds of data fields, data elements, like the CPU time, the duration, and the value, page server reads and the value, and so on and so on. Okay, so this is the XML of a single event. And then I select from the CTE, cross-apply nodes, and I get the values to get it in a tabular format. You record set. So these are the events we have. So you see, we have two types of events as I defined in the event session. We have the batch text for each one of them. Okay, this is a secret. This is what I do in the problematic application to make problems. Okay, so some of the things here are RPC completed. I run stop procedure from the specific application that I use. Some of them is SQL batch completed, like not this one. Here, this one for select customer ID. It's this query, and we have the wait for delay 5 seconds. It's more than 100 milliseconds, so I got this one as well, and so on and so on. Okay, so this is one thing. And in this case, I get the event date time of each one and the duration in microseconds. I can get a lot more values. This is just an example. The CPU, the reads, the writes, the row count, and so on and so on. And of course, once you have this in a table, you can then analyze it, group by, whatever. Okay, so this is the first example. Whenever you don't need to run to the event session to be active, then you should stop it. Okay, otherwise it will continue to run and consume resources and make the files larger and larger and larger. So stop it when you don't need it. And if you don't need it at all, then of course drop it. Oh no, sorry, this is something else. Here I want to show you something else. I'm not dropping the event session yet. I'm dropping the target because I want to edit again and to show you some other techniques. In this case, usually in the demo, I run this query quite fast and then you don't see any results. In this case, I waited. You don't see results very quickly because by default, it uses a buffer. Extend events uses a buffer before it writes to the target, regardless of what the target is. And the default for flushing from the buffer to the target is 5 seconds, if I remember correctly. Okay, so it might take 5 seconds before you see the results in the target. If you need it faster, then you can change it, for example, to 1 second or whatever you like. Okay, so it's called the max dispatch latency. Okay, so I'm doing, oh, sorry. I need to run the drop first, drop the target, and then edit again with max dispatch latency of 1 second. And then I start again. And this one again. Okay, I don't need to show you that, you get the idea. Now I'm going to stop it and then drop the event session altogether. This is the first demo. If there are any questions, feel free to ask. I'm moving on to the second one, monitor logins.
There is one question from Peter.
Yeah, sure.
Will the scripts be available for download somewhere?
Absolutely. I will publish them on my blog, and if there is another way, Magnus, if I can send them to you to publish somewhere, let me know.
I'll publish a link to the blog post where they are.
Sure.
On the SQL Friday website when I publish the video.
Sure. Okay.
Cool.
Thanks for the question. Let's monitor logins. Second demo. So I'm going to create an event session, in this case called monitor logins. I want the login event. And remember, we talked about customizable fields. Here is an example of a customizable field called collect options text. I set it to 1, to true. I want to collect options text as part of the login event. I will show you in a minute what it means. And I also want to use global fields, actions. In this case, I want the client application name and the session ID. Okay. I also want a SQL batch completed with the same global fields. Okay. I don't have to, by the way. In this case, I want for both. In many cases, you will want the same global fields for both events, because again, you're going to eventually represent it in a tabular format, and you want to have the same data for all columns, but you don't have to. Okay, sometimes it makes sense to use a global field for one event, but not for another one, so you get null in your end result for the second event. And in this case, I want to write to the ring buffer target, which is memory. Let's create a ring buffer. So unlike the event file target, in this case, in order to read from the ring buffer, we actually query the DMVs. We have DMXE session targets and DMXE sessions. And I want the target ring buffer and the session called monitor logins. This is the name of the sessions that I gave it here. Okay, so this will give me target data is an XML column. It's actually a string column. You have to cast it into an XML, which will hold the XML for all the events. Okay. Now, one thing to know about. Okay, so in this case, we have already 2 batch completed, which is what I ran myself. One thing to know about the ring buffer event compared to the event trace file. In the event trace file, as I showed you earlier, each row represents a single XML representing a single event. In the ring buffer, it's one big XML file, XML document, okay, representing all the events together, which makes it problematic in all kinds of ways. Okay, it might be truncated because you have not enough memory. It might take a lot of time to query this XML and to get data from this XML. So it's not very convenient to use ring buffer. If you want to use it for very small things very quickly without having to deal with the file system and permission and stuff like that, then it might be very easy to use ring buffer. But for something that runs for longer and it needs to capture more data than just I don't know, a few kilobytes or megabytes, then use the event file or something else. So let's do this. New query. This means I do a login from SSMS. And let's query it again. Many rows here. So this is 79. As you can see, session 79, session ID. So here's 70. This is the login event for 79. And this is the option text that I set in the customizable event. I want to collect it. Okay, so it gives me all kinds of information about what the driver does behind the scene as part of the initialization. Okay, so it sets whether if to on, set readable to off, set numerical to roundable to off, and so on and so on. Okay, and then I have some SQL batch completed as part of 79. So for example, look at this one. I didn't do anything. I just clicked new query. So these are some of the things that SSMS does behind the scenes. Okay, each one is a batch. So it checks for the addition to make sure it's whether it's a SQL Server on-prem or Azure SQL or Synapse, and it needs to behave in different ways. Check the system user, set some other global fields and session set options, so on. Select the session ID, and so on and so on. Okay, so you get the idea. This is just to monitor logins. And then I want to show you the next demo, how to track login usage with the histogram, as I promised earlier. So another event session, login usage, the same login event. This time I need only the login event. I don't need SQL batch completed. And I want to add the server principal name, which is the login, SQL Server login, as a global field, as an action. And this time I want to use the histogram target. And for the histogram target, I need to set the filtering event name and the source. Okay, so the filtering event name is, of course, login. Sometimes you might have many different events in the same event session, and then you need to specify which event is it. In this case, there's only one, so it makes sense. And the source is server principal name, which is this. Now, the source is the, think about it, is the group by. Okay, I want to group by the source, SQL Server server principal name, and then whenever there is an event of this type, login, increase the count by 1. Okay, increment the count, and then I want to count how many events of login you have per server principal name. That's the idea. And since it's only counting, okay, the footprint in memory is very, very low. It's a very small structure. Start it, and then we create the histogram. So to create the histogram similar to the ring buffer, you just change the target name here. Other than that, it's the same query. And then the external query, of course, we want to get different values. So we want the value of the base element, which is the login name in this case, in our case. And then we want the attribute count, which is the count. And if we run this, so currently we have nothing. Let's start with a new login and see what happens. Okay, so this is my login, and surprisingly, we have a login counter too. I just clicked once in query. The reason we have to, I just showed you earlier that SSMS does all kinds of things behind the scenes. It doesn't just run statements behind the scenes. It also opens several connections behind the scenes. So sometimes for a single connection that you open for SSMS, you get even more than 2. Sometimes I see 4 or 5 even, because it starts a connection to check something, closes the connection, started something else. Everything happens behind the scenes, but there are many, many connections. And it might be surprising what the hell happened here. Okay, so it's not a bug. It's not your fault. It's okay. It is how it is. Let's do something else, just as an example. Let's create a new login very quickly. SQL Server login. Let's call it me. And password would be something very stupid. Of course, I need to click this. Okay, and then let's do another one and change the connection here. SQL Server authentication. That's me. That's the stupid password. Then we go back here, run it again. Okay, so again, you see I have now 3 and already 8 for that, and so on and so on. Of course, it's not really interesting, but in a production environment, this can be very useful to understand what's going on, which application uses this database, which is not using this database, how many times, and so on and so on. Okay, and it's a lot more efficient than to monitor all the login events and only then analyze them using a query with a group by. Okay, so
I have a question around this.
Yeah, sure.
For the histogram, can I add more than one, let's say, group by columns?
Actually, that's a good question. I think not, but now that you're asking, I'm not sure. I need to check. Okay. As far as I remember, no, you have just a single column here. And what you need to do, if you need more than that, then yes, you need to either monitor the entire data set and then do it with a group by later, or combine several event sessions and join the data together. But as far as I remember, there is only one column. I need to double check that.
Next question is from Eric.
Yes.
You said histogram occupies a small part in memory, but you can still watch live data, for example, wage. So a lot of data that are later grouped into histogram. What happens to that data? And I assume that means that data would be the live data. Are they discarded when written to histogram target?
Okay, so good question. Of course, even with a histogram, if you have lots of different like weight types, or depending on what's maybe logins, okay, it can grow, absolutely. Okay, depending on what you want to monitor, your data. Remember that you have different target attributes. I didn't show them here, but you can configure the size of memory that you allocate for each one of the targets in memory, and you can also configure what happens if you reach memory, whether to stop the event session, whether to throw events. There is an option to throw only a single event, and then you need to stop it. So you can configure that. But yes, in some cases, you might not have enough memory. And then you need to either optimize your event session or maybe, again, monitor everything into a trace file and then analyze it later. Okay, but I think that from my experience, at least, in most cases, when you use histogram, you usually use relatively small amount of data in the histogram itself.
Now, I think when it comes to the watch live data functionality that you have in SSMS, that is going to add actually another target, which will be your buffer that you are looking at. So it's not the actual histogram target. It is another target that is added from SSMS. Oh. You click the watch live data button.
Good to know. I didn't know that. I don't use the GUI very much, so thanks for that. Okay. So I think I'm done with this demo. Close some things here. Does it happen to you too that you start opening sessions and 2 hours later you have like 30 different tabs here? You don't know which is what? Every day, yeah. Let me close. Okay, done. Great. Let's move on. The one before last demo is execution timeouts. It's an interesting one, and I will do it in 2 different ways to show some things about extend events. Let's start with option 1. So I want to monitor for timeouts, application timeouts. Okay, sometimes you have timeouts and you don't know where it comes from or why or when and so on. You want to monitor those events. Let's see one option to monitor timeouts, and then I'll show you a better option to do it. So the first option, the first idea is to use the pair matching target type. Now the pair matching target is a very interesting one. What it does, you configure, you define 2 different events. One of them is the starting event, and the other one is the ending event. Okay, begin and end. And I will show you some examples. And then when the starting event is captured, you get the event in the target. And you can see the event there. As long as the ending event relating to the same starting event is not coming, you will still get the event in target. As soon as the ending event is coming around and it's captured, then extend events deletes this event altogether, the starting event. So what you get after some time, only the starting events without a corresponding ending event. Okay, and there are all kinds of use cases for that. One of them, for example, is an application timeout. What I'm going to do here, I'm going to use SQL statement starting and SQL statement completed. Okay, so if we have a SQL statement starting without a corresponding completed, one of the options, not necessarily, is that we got a timeout and it wasn't actually completed at the server level. Okay, so here's how we're going to do it. Add event SQL server starting. I want all of those actions, global fields, session ID, T-SQL stack, database name, and so on. The same for SQL statement completed. The target will be pair matching. And then this is how I define the pair matching target. I need a begin event. In this case, it's the SQL statement starting. And begin matching actions. Okay, so in this case, I want to take session ID and T-SQL stack. Okay, and this is why I bring those 2 here and here. So if I compare the session ID and the T-SQL stack between the starting and completed, this is the same batch, the same request in this case. Okay, it's the same T-SQL stack within the same session. It's the same one. So this is how I track the corresponding completed event for the starting event. The same for the end event, completed with the same matching actions. And again, just as an example, one of the configurations you can do with the pair matching target is respond to memory pressure. Okay, so whether you want to give priority to the event session to continue and track, and if you can't, this means that if you can't register the events, then the request that was generated the event will have to wait until you can. Okay, or otherwise you're going to lose events to give the application priority to let it move on. So whether you want to respond to memory pressure or not, we saw max dispatch latency already before. Let's run this and start the event session. And you're already familiar with the structure of this query. Okay, so currently nothing. Let's simulate some timeouts. Oops, sorry. Okay, so what I'm going to do, first I'm going to run this, wait for 15 seconds, and I'm going to run this again. Okay, so I get this statement currently because we have the starting event, we don't yet have the ending event. As soon as it's done, it's not going to appear here anymore, it's going to be deleted. So let's wait a few more seconds. Okay, now it's done. Let's do this again. It's gone. Okay, because we have a pair. As soon as we have a pair, it's not here anymore. We only get the starting event without the completed event. So as you can see, this is not exactly showing me only application timeouts. Also shows me requests that are running for a long time but haven't ended yet. Okay, so this is one problem with this option, but I just want to show you some options, some use cases. Let's continue to the second demo here. So I'm going to create a table called new payments. I'm going to begin a transaction, and now I'm going to actually run a long-running transaction. So it's going to appear here, my insert. Then I'm going to stop it. Okay, which is kind of a timeout. Okay, I'm going to stop it from the application side. And if we run this again, okay, so it's still here. So because I stopped the application from the application side, I send a stop request. It's called an attention, I think. Then from SQL Server side, the batch wasn't completed. It doesn't register in a SQL batch completed event. Okay, and for that reason, we can capture timeouts using this mechanism with the pair matching, as you can see. Okay, but again, it's not good enough because you can get different types of events and you don't have all the information that you need. I'm going to show you another option later. Just to do this, let's roll back here. We're done with that. And just another example, again, sorry, here. Okay, I'm going to go back to the wait for, but before that, I'm going to change the connection properties. The execution timeout, let's say 5 seconds. Okay, and this is like the command timeout if you're doing it from a .NET application, for example. So this means within this session, every request that will take more than 5 seconds will be aborted from the application side, just like clicking stop. Okay, so now I'm going to do this again. We're going to come here. We see the wait for delay, and after 5 seconds, we're going to get execution timeout expired. Okay, and it's going to stay here for the same reason. Okay, so another way to show you timeouts and how we can capture them. So this is option 1. And there are other interesting use cases for the pair matching event. Think about orphan transactions, for example. You want to monitor for transactions that are started and never committed or rolled back. Okay, they keep their active holding locks, for example. Then you can use 2 different events. One of them is begin transaction, the other one is commit transaction, and then you know what to do. Think about locks. Okay, so you have acquire lock and release lock, and many other similar use cases for the pair matching event. Sorry, targets. Okay, now let's see option 2. So option 2 is a lot better. In this case, instead of the pair matching, what I'm going to do, I'm going to use this. One of the fields we have for the SQL batch completed and also the RPC completed is the result, and 2 means abort, which is actually basically an application timeout. Okay, so this is one thing, and I also want to get the attention event. Attention is when you have a command timeout, or again, like the stop button, it's called an attention. So I want RPC completed and batch completed, only those that are aborted, and also the attention event. And I want to write it in this case to an event file. And the interesting thing here, the new thing here is this track causality, okay, which by default is off. I set it to on. What this means, it adds a field called activity ID for each one of those events. Okay, and if events are related, so in this case, if I run a batch and it's completed, but it's aborted, and then we have a rollback. Okay, so we get also the attention event for this specific request, for this specific batch, and they will have the same activity ID. So this will allow me later to correlate between them and could calculate the time of the batch itself until aborted, and then the time of the rollback, for example, and so on and so on. Let me show you how it works. So let's create this event session first, and then start the event session and monitor client timeouts. So what I'm going to do here, I'm going to use first this from the event file. Then I'm going to select all of those values. And look here, I also have the activity ID, attach activity ID, okay, which is attached to all of the corresponding events. And then I'm going to use the nodes, get the different fields. So this is the first CTE. And then I'm going to select from this CTE. I'm going to cross-apply nodes again to get the events. And well, whatever, eventually, I'm going to have the batch completed events. Oh, sorry, let me explain it better. So this is the batch completed events CTE, which gets all the events of type SQL batch completed and RPC completed. And the second CTE is called attention events, which gets all the events of type attention. Okay, and of course, in both of them, I want to get also the activity ID. And then the main select statement inner joins between the 2 CTEs, and it's based on the activity ID. So this is how I correlate between them. And then I want to get the things like the application name, host name, and so on and so on. But the more interesting things are the batch start time, which is we take the event date time of the batch completed events, okay, and we have the duration. So we do minus the duration, we get the start time of the event batch, and then we have the duration in microseconds, and then we have the end time, which is the event date time of the batch completed. It looks wrong, right? Oh, sorry, the attention. Okay, less the attention. The batch. Okay, this is what I want to explain. You have the batch completed event. The batch completed event, the date time would be at the very end. So if you have a session, a request, sorry, running, at some point it was aborted for all kinds of reasons. It needs to roll back, right? So you have the time of the actually running the request, and then you have the time of rolling back. The batch completed event will have the date time of the very last date time of after the rollback, okay, when it's all done. The batch completed event duration, the duration here gives you the duration of the actually running the event, the request, and the attention duration is the time of the rollback, okay? So by doing some calculations here, I get all the different values that I need. Let's just look at the results. I guess it would be easier to understand. And yes, you will get the script, so you can get it, see it for yourself later. So now there's nothing. Let's simulate that again. So now I'm going to run this one. Remember that we have a limit of 5 seconds, execution timeout. So it's awaited up for 5 seconds. And if we look here, so now we have a lot more information, okay? So we know where it comes from and so on, client process ID, the database name, and so on and so on. We have the SQL text. So it started at 10:53:41 seconds. Okay, it took 5 seconds. The execution time was 5 seconds, and then the execution end time was 41. This is 46. 5 seconds later, and this is the time of the cancellation, the rollback. Now, in our case, it's a wait for delay. There's nothing to roll back, but there is still some time to do a rollback to kill the request. Okay, so it took 190 microseconds, and this is the actual batch end time. Let's look at a more interesting scenario. Let's run this again, begin transaction. And this, it will do some stuff. It will insert data for 5 seconds, and then it needs to roll back. So after 5 seconds, it needs to roll back. This was very quickly. Too quickly, if you ask me. Let's see. Yes, okay. So we have 5 seconds execution time, but another second and a half, right? Yeah, 1 second and a half more or less for the rollback time, and you get all the information that you need about those timeouts. Okay, so again, a better way to monitor timeouts. And let's close this. And I still have enough time for the last demo. Yeah, whatever. Okay. Statement waits. This is a very common use case, very common request to monitor waits. You have a very long running query and you want to know what is it waiting for. Okay, sometimes it's a single wait type, sometimes it's different wait types. You want to monitor what are the wait types that happen during a specific query execution, and which one took the longest time, and so on, things like that. So one way to do it, by the way, is okay. I will talk about it later. Sorry, I didn't say anything. Let's start with this. SQL statement starting. I want a SQL text. I want a specific session ID. Okay, so let's do this. I have here a session that begin transaction, then update sales order headers. I want to lock the table. Okay, I'm going to hold those locks. Then, sorry, this one, wait for locks. I'm going to run this, which will wait because of the lock. Okay, and I want to show you the wait types. So let's go back here. I want to monitor this one. So it's 56. So I want session ID 56, session ID 56, session ID 56. Okay. So I want the SQL starting, SQL statement completed, and also the wait info. So the wait info is an event that gives me every wait, every time SQL Server registered a new wait, a waiting task, then we're going to get an event here. I will show you how it looks like. And optionally, you might want to add a duration filter because sometimes a single wait might take less. This is in milliseconds. and sometimes a single wait might take less than 1 millisecond. So it's going to appear like 0, and you have many different waits for just like a 1 second running query. It's going to blow your file or memory, whatever. So you might want to add some filtering to only look for waits that took more than 10 milliseconds or whatever you want to put there. In this case, let's put it in the event file name. And here is an example of event retention mode. Allow single event loss. Okay, just to show you some example. It's not really related to what we're trying to do here. And let's do this. Let's start the event session. Here the event file. Okay. Yes. Now I'm going to run this query. Might wait for the locks. And let's do a rollback here. So now it can completed. If we look here, you can see all the waits related to this specific request. So you get starting. No, not this one. Okay, this is something that the system does behind the scene. Here it starts. Okay, so we have starting of the select top 10. Then we have a wait info of the lock, the shared lock. I need a shared lock. And as you can see, for wait info, we get two types of events. We have a begin and an end. It starts with begin and then end. So this is the begin. And then at some point, 5 seconds later, we have the end. Okay, we also have SOS scheduler yield, but for like nothing. Okay, it's 0 because it's rounded up to 0. It's less than 1 millisecond. And then at some point, we have the completed. Okay, which is the total time of the request. Okay, so as you can see, you have all the waits there. Now, something else. Let's do this. If we go back here, then we have again a wait with a wait for wait type. Okay, and then the begin. And of course, as soon as it's done, we're going to get the end as well. You see here, end after 15 seconds. And again, let's do this. So this one is going to do real work. Okay, let's let it run. Stop it after a while. As you can see, now it takes a long time just to get the events from the file. Okay, because there are many events. Doing this insert, now we get real events, real waits. Okay, not just wait for waits. We get waits like CX packet, like page IOLH, things like that. And those waits, it's not one wait type that takes 10 seconds. It's millions of waits. Each one takes a few microseconds. Okay, and since we didn't filter by duration, you get many different events. As you can see, lots of CX packet with a 0 event duration. And this is, by the way, unfortunate because this duration field is in milliseconds. And as you can see, if you really want to sum up the values, you will not get them properly. But it's good enough, okay, to get an idea of what the wait types are. As you can see, this is a lot. So one option, you might be able to use the histogram, for example, okay, to get a better view of this without having to analyze all of the data. You can filter by the duration, for example, which might be good enough to get the real interesting weights. Or you can get all of the data like I'm doing here, and then you can aggregate the data. So take the information and then run a group by the weight type, and I want to do the sum of the event duration. Then we can get something like this, Come on, day, please. Any question? This is a good time for questions, I guess. Oh, we got it. Okay. So yeah, in this case, we had the wait for, and then the second statement, the biggest one is CX packet, and then the lock, and so on and so on. Of course, if you do this for a single statement, it will make more sense exactly what happens within the statement. In this case, it's several statements together. Or you can group by the SQL statement as well. Okay, so this is a great way to monitor SQL weights. And what I wanted to say earlier is within the execution plan, starting at some point in time, I don't remember which version, but as of today, if you look at the execution plan, you have a section of the wait info. Okay, so you actually get all the wait types that happen during a specific plan or a specific query, and how much time was spent on each one. which is basically what I try to do here. But from my experience, when I use the information in the execution plan compared to running an event session like this one, I get different results. And I know from others as well that they get different results. So I don't exactly know if it's a bug, if it's something about the way extend events capture the data. I don't know to tell you which one is right, but just be aware that it's not, sometimes it's really completely different, okay? So there is some bug there, okay? I don't know exactly what, but take that into account when you work with the data. I tend to trust the extend events more because I know what I'm doing, okay? I see the events in my own eyes. I don't know exactly what Microsoft collects behind the scenes for the execution plan, whether it's correct or not. So again, just take that into account. And where is my presentation? Here it is. Okay, so just let's summarize. Okay, this is an old presentation. It's not the new kid in town. It used to be. It's really, really, really not new anymore. But compared to Profiler and SQL Trace, it is. Okay, it has less impact on performance. Even if you do the same thing with extend events and SQL Trace, it has less impact. And of course, you have the ability to use different targets like the histogram and pair matching, which you don't have with SQL Trace. You have many, many configuration options. I show you just a few here and there. There is GUI. As I said, I don't like to use the GUI, but feel free to use it, of course, to configure the sessions and also to watch live data. And yes, you need to get used to it. If you're not working with extend events yet, it takes time to get used to it, to work with XML, to work with the different objects there. But once you get used to it, it's very, very powerful. I can tell you that. Again, the best resource, if you ask me, is Jonathan Kehayas about extend events. And there's another, let me find it. Here it is. Another thing I want to recommend, and I'll put the link in the comments, in the chat. Here it is. Jonathan did, many, many years ago, he did a series of X event a day, 31 blogs. It goes backward, okay? Each day on a different topic related to extend events. And this is a wonderful resource. I learned a lot from this back in the days. I really recommend if you want to learn extend events from the beginning in a very, very comprehensive way, this is a great resource. And, oops, I clicked it. Sorry, didn't mean to do that. And that's it. If you have any questions, anything now or later via Twitter or email address, feel free to do it. I will post the presentation and scripts on my blog post, and I will send it to Magnus as well. And I guess that's it.
There is a question that I have waited with, which is from Antonio. Is it possible to collect the extended event from a query and store it in a table and using deltas from the last stored record? And how can it be done?
And using what again? Sorry.
Using deltas to kind of track the. I mean, all I have is the text from the question, but.
So what I can say is you don't have table as a target, like you do, for example, in Profiler. You can save directly to a SQL Server table. So you can save it to memory and then query it from there and put it in a table, whatever you like, or from the event file, like I showed you. So of course you can build your own mechanism to once in a while query the results from the target of extend events and put it in a table. But it's your responsibility to do it. It's your responsibility to calculate the delta in some way. There is no built-in mechanism to get deltas from extend events itself.
Yeah, that was what I was.
The question.
I think it does. I have one question, which I don't know if you can answer it, but do you know why the XML structure is not stored as XML? I mean, in the results set, it comes back as text.
Right,
you have
right.
to be called to XML. Do you know why? Have you asked any?
That's a good question. I didn't ask. It's a good question, but yeah, maybe I should ask someone about that. I don't know why. It's weird because we have to cast the XML every time. Why? Just give me it as an XML. That's it.
Yeah, and since it is an XML, I'm pretty sure that initially it is a binary structure in the code, and then it is converted to a string to be able to be returned to our result set, and then we have to cast it back to XML. So it doesn't make sense to me, really. But
yeah, I agree.
SQL Server works in mysterious ways sometimes. So.
Yes, indeed.
We have many thank yous for a great presentation. I agree with all of them. It was a great presentation, and I really love that it's as usual when you do something, it's very demo packed, and I like that because it's, at least for me, I learn from practical demonstrations more than
I like that
from
too.
So it's really good, and I think the scripts you provided are a very useful start for extended events. And from there, for those of you watching, if you haven't worked with extended events, start here. And I would say whenever you have like a monitoring or analysis problem at hand, you want to know something, what's going on. There is an extended event for it, I am sure. I mean, there is for everything. I played a bit with extended events for when the optimizer is doing the row count estimations during optimization time for a query. There are tons of extended events to find out what things did SQL Server consider before coming up with which algorithm to use, and you can really find out the internals of SQL Server by exploring the extended
when you want to learn about a specific topic, you want to troubleshoot some area in SQL Server. I give an example. Just a few weeks ago, I had a case when I wanted to troubleshoot transaction log flushes in some custom environments. Okay, which is when SQL Server takes the transaction log from the log buffer to the LDF file on disk, okay, with the write log event type, wait type. Okay, so I wanted to troubleshoot and to understand exactly what's going on in there during this process because I needed to understand it. So what I did, and this is something that I do once in a while, you first go to the extend events DMVs, which I showed you in the beginning. Okay, you write a very simple query, show me all the event which has, let's say, log or flush in the name. Okay, like percentage flush percentage, and then you get a bunch of events. One of them is log flush, which is what you expected. Some of them might surprise you. Okay, you got all kinds of events. Oh, it also does that, and there is this event and that event. I want all of them, and then you take all of them. Then you create an event session that puts all of those events together, write them to an event file, and then you start simulating something. Okay, you do an insert or an update or whatever, and then you look at the file, sort it in datetime chronologically, okay, and you can learn a lot from just viewing this for a single statement. You see what happens. Okay, it writes to the log buffer, and then it waits for something, and then it's write to the transaction log, and then it commits, and so on and so on and so on. And you learn exactly how it works behind the scenes. You can learn a lot from doing this for many different areas.
I agree. We have from Eric, excellent content, 5 out of 5. Maybe slow down a little. At the start, I thought I had activated 1.5 times speed by accident.
I get that a lot. Sorry, I really try. This is me being slow. This is my slow version. Sorry about that.
No, but it's the only way to pack 90 minutes contents into 60 minutes. So I like it.
I guess. Yeah, sorry. But it's recorded and you can watch it for slower, right?
Yeah, exactly, and do it in 90 minutes. Perfect. Regarding the new kid in town, extended events as a teenager this year.
Yeah, right.
Because it came in 2008, right? Yeah. So it's 13 years old. So if you're still using trace, any one of you, don't do it. You didn't touch much on why trace was replaced by extended events initially, but trace has an overhead that, I mean, extended events also has an overhead, but it's not near the overhead of a trace. Yeah. So don't use trace.
Right.
And also, I think the biggest difference is that the extended events are asynchronous, whereas trace is synchronous. So what I've seen many DBAs do is to open like a live profiler session, which will in the background start a trace. So every query that is captured by the trace has to wait for it to be displayed in your profiler. Don't ever do that. Not even in development environment. This is a bad habit. So.
Yeah. Well, I know people that it's very convenient for them. I understand why it's very convenient, very comfortable to use that. And if you do that in your dev test environment or whatever, I guess that's fine. But you really need to understand the impact. So if you get used to it, and then by intention or by accident you're going to use it in production, it's not going to be very, very pleasant. So the message is get used to extend events, and once you're used to it and you feel comfortable, use it every time.
I agree. We have one, there was a mistake with the link, I see. Morgan types that the link to the blog doesn't work. So what could it be?
You're right. You're right. Sorry about that. Let's do it now. My bad. Probably no link.
Okay.
I'm not sure that I can. Anyway, here's the blog. I'll put my post there. Sorry about that. In the chat.
Perfect. Thanks.
Thanks for that. We'll fix the presentation.
So I'm going to let you go back to, you know, whatever you do when you're not presenting. I assume you also have to do some paid work during the days, which
sometimes
I find that it often gets in the way of my you know, what I want to do, but it's easier to pay bills with paid work. So
yeah, right. It helps.
It does. So cheers for a very compact 90-minute lecture from Eric Grahn. I think will be the final words of this SQL Friday. Thank you so much for coming.
My pleasure.
And everyone follow SQL Server Radio. It's a good podcast. And
thank you.
What have you done? You're up to like 1 million episodes or something. You have been going on for a long time with it.
Yeah, I think 7 years or 8 years, something like that.
Yeah.
Yeah, quite a long time.
I don't know how you do it, but I'm impressed. So.